All right, what we are going to be dealing with today is placing all rational numbers on a number line. We need to real quickly make sure that we know what we mean by rational numbers. There's a couple of different kind of ways that we can break down all these different numbers that we've been dealing with so far this year. The three big categories of numbers that fall into the category that we can kind of break things up into. We can say, first of all, there are whole numbers. And whole numbers consist of any number that's a distance of 1 to the right of 0 on the number line. So the number 1 is the distance of 1 from 0. The number of 3 is 3 units of 1 from 0. The number 8 is 8 units from 0. The number 0 is 0 units of 1 from 0. The next category that we can sort of break things into is integers. And integers can kind of be seen in two major categories. You have positive and you have negative numbers that are all distances of 1 from 0. So 4 is 4 units of 1 to the right of 0. It's a positive number. The number negative 4 means 4 units of 1 to the left of 0, which would be negative 4. And you know, technically, 0 is sort of in its own little world. But the last major category is rational. Now, it's important to note that all whole numbers are also going to be integers, right? Whole numbers sort of make up the positive side of integers. Rational numbers can be sort of represented in one of two ways. You're going to see rational numbers represented as fractions. So 3 over 5 is a rational number. Negative 7 over 2 is a fraction. And these are all therefore rational numbers. And then we have decimals. And decimals, 4 is a decimal, right? 4.0, that's a decimal term. Negative 3.25, this is a decimal number. And if you recall, decimals are really just fractions with a denominator of 10. But we do they look different, and they are used in different ways. And so it's important to kind of see these distinctions. So rational numbers are pretty much going to be made up of whole numbers, right? 5 is 5 over 1, which is the same thing as 5, which is a whole number, and an integer. And then, so just to kind of look at this left and right, all whole numbers are also integers, and all integers are also rational numbers. Moving forward, we need to be able to place numbers on a number line. And now whole numbers are pretty easy to put on a number line. If we say 9, we mean, well, where is 9 on the number line? Because our number line is just units of 1, right? So that corresponds with our definition of whole numbers. There we go. And 1 can get moved over here. Now, negative numbers and positive numbers are both placed on the number line sort of the same way. Once we get into integers, it's the same thing. Negative 5 means 5 units of 1 from 0. Well, in the negative domain, these are still units of 1, right? So negative 5 is there. Negative 6 is there. Negative 3 gets put over here. 8, hey, it's pretty close right there. This also is where we need to start talking about how we can compare the size. You see, numbers get bigger as they move to the right on the number line, period. Therefore, 13 is further to the right, it'd be over here, than 8 is. And so that means that 13 is bigger than 8. However, with negative numbers, the larger the number appears from 0, right? Negative 13 means 13 to the left of 0. The smaller it's going to be, right? Negative 13 is going to be way over here, while negative 8 is right here. And therefore, negative 8 is actually a larger number than negative 13 because it's further to the right than negative 13. So I ask you to order these numbers from least to greatest. And we can actually do this just by simply putting them on the number line, right? From least, the least, negative 15 is going to be way over there. Negative 8. So negative 15 is the smallest because it's way to the left. Then we have negative 8. Then we have negative 3. The next number to the right is 5. And then the number furthest to the right, or the greatest or largest number, is 10. All right, so sliding on down. No, come back. Uh-oh. My computer's running a little bit slow. Sorry about that. So now we need to take a look at rational, putting rational numbers on the number line. When we see 3/4, we need to remember what that means. That means each distance of 1 is broken into 4 parts, and we're talking about the length of 3 of those parts. So this number, right, if we break up the distance from 0 to 1 into 4 parts, we can kind of go 1/4, 2/4, 3/4. And I'm not looking for it to be exact. We say approximately, and that's about where 3/4 would be. Same thing, I have 15 over 4. Well, let's see. If we break them into fourths, well, that's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Hey, right about there. Mixed numbers, right? This is, instead of, notice how we kind of counted over a bunch of whole numbers to get there? A mixed number tells us how many whole numbers to go, and then the fragment length. So we've got 3 and 6/7. So 1, 2, 3, right? And then 3 and 6/7. If this is broken into 7 parts, right? Then we would go boom, 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 and almost there. That's where that number would exist on the number line. I'll kind of put it up here so it's a little bit less messy. And then same thing over here, negative 8 over 5. So 1, 2, 3, 4, 5, 6, 7, 8. That's about where negative 8 over 5 would be on the number line. So then in class, I would ask you to kind of put some of these out on your number line as well. And to be able to order these numbers from least to greatest. This, once again, can be easily done just by putting it on the number line. So 12 over 4, well, let's see. That's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So 12 over 4, and yeah, that makes sense. That's the same thing as 3. Negative 4 over 5, well, negative 1, negative 2, negative 3, negative 4 of when we divide it into 5 segments. 3 over 5, right? This is a positive number, so we're going to the right 3/5. So 1/5, 2/5, 3/5, be just a little bit over halfway. And then negative 6, I'm going to go ahead and start off there. And now 1 2/3, right? If the negative is in front of the 6, then that means the 2/3 is also negative. And then in class, I would ask you to do the same thing here. Now, decimals work the same way, okay? So we have 0.3, right? So this is a number less than 1, right? And so we need to break our number line up into tenths, and we're going to go up 3 of them. 1, 2, 3. About right there would be where 3/10 is. 4.2, so we're going to start off at 4 and then go up 2/10. So 1/10, 2/10. 0.718. Okay, so I need to go up 7/10. So I'm going to go up, let me get an arrow here. That'll make it a little bit easier to see. Plop. And let's make that a group. There we go. All right, so I'm going to go up 7/10. 1, 2, 3, 4, 5, 6, 7. And then the 1/8, that means now I need to go up 1/100th, which would be just the teeniest bit. And then 8,000. So, I mean, we're now in teeny land. But if we're approximating, if we're just getting close, then that's going to be good enough. That's clearly, 0.7 is over halfway. This is clearly over halfway. It's not all the way to 1. So that's approximately where 0.718 would be on the number line. Here, negative 7. So I'm going to start off there. And then I need to go 9/10. And it would exist somewhere. Somewhere right about there. 0.9. That's pretty close to negative 8. Same concept. And this can kind of be done if we're dealing with these numbers that are pretty close in size. We can compare them just by looking at their place value, right? So if we were to put these on a number line, both of them would go to the right 4. So far, these numbers are equal. So now we look at the next unit. We say, okay, well, then we've got 5 and 5. So after we go over 4, we would go up 5/10 for each number. So they're still at the same place. But now this one only goes to the right 1/10, and this one goes to the right 3/10. So this number right here, this is the bigger number. So, you would do some in class. Scroll down a little bit more as my computer runs really slowly. And then in class, I'd ask you to organize these just from left to right on the number line. And then we need to start being able to mix these together, right? We need to be able to say, hey, okay, so negative 2.78, that's going to be negative 2.7 tenths, so somewhere around there. And then this number right here, negative, so I'm breaking up into thirds. So 1, 2, 3, 4, 5, 6, 7. Okay, so negative 7 over 3 is a little bit larger of a number than negative 2.78 because it's further to the right. So that's just an overview of how we put numbers on the number line. I mean, there's not a lot new going on here. We're just putting it all together so that we understand how to compare fractions and decimals. If you go to a store and one store has something 25% off and the other one has something a fourth off, you need to be able to kind of compare those and say, hey, wow, that's the same thing. So I hope that helps. Thank you very much.